During recent GameStack event, Microsoft presented a live tech demo of Xbox Series S and X velocity architecture and sampler feedback streaming. Following material presents how fast asset streaming is from an SSD. It also presents massive savings to memory utilization and bandwidth. So without any further ado, here's how the velocity architecture works.
Let's take a look at how you can use game asset streaming.
The scene you're looking at was built to a very high level of detail so that the objects can be inspected up close. Over 10 gigabytes of texture content are present in the scene, and we use texture streaming to hold only some of that content in memory at any given time. A traditional texture streaming engine decides to load texture MIP levels using a coarse measurement of which objects are visible and how large they appear on screen. These measurements can be inaccurate, leading to over or under streaming. This memory size is known as a texture budget, and in most titles, the texture budget is the largest single user of title memory and the largest single user of storage. We can estimate what an optimized Generation 9 traditional texture streaming engine would need to have in memory to render what you're seeing right now. It's still a conservative estimate, by the way. Most game engines would likely use somewhat more memory than you see here due to overstreaming. But with sampler feedback streaming, we can use significantly less memory to render the same scene, and a corresponding reduction in the amount of storage we use to load the data into memory. That means that for the same scene, we're loading it faster on Xbox and using less memory than on competing platforms. We think of this efficiency gain as a multiplier on our storage performance and our graphics memory size. With this view of the scene, the value is 3.0, and you'll see the value change as I move around the scene. I should also mention the absolute numbers you see in the memory bars here. They aren't all that high, especially compared to the 10 or 16 gigabytes of memory in our consoles. Our content in this tech demo is fairly simple. A real AAA title would likely have significantly more complex materials and more objects visible. Crucially, however, the comparison between sampler feedback streaming and traditional MIP streaming holds true regardless of material complexity. The numbers will scale with content, and the multiplier will still ring true. Let's compare a Generation 8 traditional streaming engine on a hard drive to sampler feedback streaming running with the Xbox Velocity architecture. I'll start the scene reload now. This camera angle consists of over 2 gigabytes of texture data and simulating a hard drive from the Xbox One X console. It'll take a while to reload all of the data needed to render this scene with its ideal level of texture detail. From talking with title developers, we know that texture streaming is as much art as it is science. Various techniques are used to estimate scene visibility and size for each object, and then calculate how much texture detail must be loaded for each object to make the scene look great. Most titles do complex offline processing to make these estimates better. Some titles show a load screen while textures are streaming. And even after all of this engineering work is done, artists usually need to manually adjust some objects and textures to fine-tune the results. It works, but it's a lot of work. After about 22 seconds on a simulated Xbox One X console, we're done loading. Now, we reload the same scene using sampler feedback streaming from our solid-state drive. It takes less than a quarter of a second. If you missed it, let me replay it for you. Sampler feedback uses the GPU to automatically determine the exact set of texture data needed to render the scene with the ideal level of detail. Our solid-state drive, hardware decompression block, and optimized direct storage API gets that texture data into memory extremely quickly. The Xbox Velocity architecture gets you into the game quicker. The game spends less time loading data that it doesn't need for that first frame of action. Additionally, you can see that I can fly around this scene and the system easily keeps up. Thanks to the efficiency of the Xbox Velocity architecture, you rarely see pop-in artifacts. When you're playing a game, sampler feedback streaming allows you to move quicker through the world with higher detail. And since everything loads so quickly, game developers don't have to use twisted hallways between areas or loading screens to cover up texture streaming. There is a ton of detail in this scene. When you get close to the drawings, you can see the texture of the paper, as well as even the pencil strokes. And you can see how the memory usage changes as I look at different parts of the scene. You'll note that the memory bars in the upper right-hand corner consist of both a light region and a dark region. The light region represents the amount of memory seen in the previous frame, while the darker region represents the amount of memory that is loaded but was not used in the previous frame. The streaming system is constantly unloading memory that hasn't been needed for a few seconds, so you can see here that as I move, and if I stop, the darker region soon shrinks to almost zero. I can even do quick camera cuts, which are difficult for most texture streaming systems to handle. Each time I perform a quick camera cut, over a gigabyte of new texture data can come into view. Thanks to sampler feedback streaming, only a fraction of that data needs to be loaded. Some games have to have a lengthy load screen, transition effect, or some sort of contrived gameplay element to hide the texture pop-in from a quick camera cut. This tech demo doesn't have any of those tricks. Sampler feedback streaming is really that fast. Earlier, I talked about loading texture pieces, I talked about loading textures piece by piece. Let's look at this drawing on the table. I've switched the scene rendering to color code the amount of detail used at each location. The colors are in rainbow order, from red representing the most detail to purple representing the least amount of detail. On the left is a visualization of which memory is loaded for the texture we're focusing on. Each texture in the game is implemented with multiple levels of detail called MIP levels. The largest MIP level, known as MIP 0, has the most amount of detail, and each successive MIP level has half the dimensions of the previous. The index of each MIP level corresponds to the color coding you see here. MIP levels are used to increase performance as well as improve image quality when objects are drawn far away from the camera. First, I'll show what traditional texture streaming does as I approach the drawing. Entire MIP levels are loaded into memory regardless of what piece of the image I'm looking at. And as I back away, the texture streaming system can choose to unload the more detailed MIP levels when they're no longer needed. Note that these MIP 0 images are rather large, 16 megabytes or larger across most of the textures in this scene. Even with a solid-state drive, it is a consequential decision to load 16 megabytes just to see detail for one texture on one object. Considering the number of texture layers on each object and the number of objects you can see at once, these high-detail MIP levels can really add up. With sampler feedback streaming, however, the system can load these MIP levels bit by bit. It's more responsive because it very quickly loads the detail only where it's needed. It's more efficient because it doesn't load the detail where part of the drawing is off camera. Think about standing next to a building or a statue in a game. You want to look at part of it up close. Sampler feedback streaming allows you to see incredible detail up close, like the placard on a statue, or the face on this drawing. And it doesn't waste time or memory loading unnecessary detail far away from the camera or off screen. With sampler feedback streaming, games can add more detail to every object, large and small, and not have to worry about compromising their entire texture budget elsewhere to make it work. Next, we'll look at this globe hanging from the ceiling. Sampler feedback streaming uses data from the GPU to stream in only the visible parts of objects. In this camera angle, the Pacific Ocean on the other side of the globe is not loaded in yet. However, as I spin around the object, the streaming system quickly loads in the newly visible parts and unloads the parts that are no longer visible. Think about an in-game cinematic when you see a character's face up close. Sampler feedback streaming allows that character to have incredible detail loaded extremely quickly, and not waste time loading detail on the other side of the character you can't see. Now I'd like to show you how our sampler feedback hardware feature works. I've re-enabled scene color coding, and I focused in on this drawing on the easel. On the left is a visualization of sampler feedback data for this one texture. Sampler feedback is configured per texture, and we are looking at just one of the 475 textures in this scene that are all producing feedback. The texture is divided into regions, and the developer chooses the size of the regions. For each region, the GPU computes the ideal level of detail used to sample the texture within that region. As I approach and pull back from the drawing, you'll see regions of feedback show higher and higher levels of detail, and then you'll see gray. Gray represents no feedback. That's because those regions are now off screen. You may also see some random flickering in the sampler feedback data. This is because we're capturing only a fraction of the sampler feedback data. The GPU is capable of providing an enormous volume of sampler feedback data, and we can carefully tune the level of output to best balance accuracy and performance. We have found that we can discard over 99% of the raw data and still get great results. Game developers have lots of ways to control the precision and amount of data coming from sampler feedback. Each title can tune sampler feedback to best suit their needs.